Hello friends, in this video let us discuss previous year electronic science paper which was conducted by UGCNET in the year June 2019. So in this video I am going to discuss question number 76 to question number 100. In my previous video I have discussed question number 1 to question number 75. If you have not watched that video, links are given in the description. Also you can click on I button. Moving on to 76th question, what they have given is the equation for f of e is the Fermi Dirac probability function and is defined as 1 divided by 1 plus exponent of e minus ef divided by kt. So the suitable option that is going to follow is option A is correct. Many textbooks, how they are going to express this: 1 divided by 1 plus exponent of minus of ef minus e divided by kt, where ef is the Fermi level, k is the Boltzmann constant, T is the absolute temperature expressed in degree Kelvin. So suitable option is option A is correct. Moving on to 77th question, what they have given is in the case of 8051 microcontroller, it is rated at 25 megahertz, nothing but it is operating at 25 megahertz. What is the maximum frequency that can be connected to? Maximum frequency how much you can connect is 25 megahertz, provided you are maintaining proper synchronization, nothing but with respect to phase, if you are matching, you can connect up to 25 megahertz. Greater than 25 megahertz it fails. Less than 25 megahertz if you are connecting, it is okay. But for faithful output, if you are connecting to 25 megahertz, it is well and good, nothing but it will be operating at high speed. So the suitable option that is going to follow is option 2 is correct. 78th question, match the following. What they have given is on the list 1 they have given the formula, on the list 2 they are talking which law it belongs to. Del dot D equals to rho V, it is Gauss law. Curl E equals to minus dou B divided by dou T. Curl E equals to minus dou B divided by dou T, it is Faraday's law. Curl H equals to J, Ampere's law. Curl H equals to J plus dou D by dou T, it is modified Ampere's law. So the suitable option that is going to follow is option 4 is correct. Which type of optical fiber is used to eliminate modal dispersion communication? So first one they are talking about single mode step index fiber, multi-mode step index fiber, multi-mode graded index fiber, does not depend on type of fiber. See, in the case of single mode fiber, what you are going to do is you are going to make use of only one signal. So there will be no any interference from adjacent one. So the suitable option that's going to follow is option 1 is correct. But most of the cases we are not going to prefer single mode step index fiber because cost is more and you are not making use of the channel bandwidth properly. The MOSFET will have higher cutoff frequency if. So they are telling GM is large and CGS is small. GM and CGS both are large, both are small. GM is small but CGS is large. So transconductance should be a large value and capacitance of gate to source should be a small value. So suitable option that is going to follow is option 1 is correct. Small signal analysis in the case of MOSFET and BJT is very important. 81st question, which of the following equation is electromagnetic wave equation given E is in the time and space dependent electric field intensity vector and mu is permeability, sigma is conductivity and epsilon is permittivity respectively of the medium they are telling. So which option is going to get matched? So it is given by del square E, which is equals to mu sigma dou E divided by dou T plus mu epsilon dou square E divided by dou T square, nothing but option 4 is correct. If at all if you are preparing for December 2020 exam or Jan 2021 exam, Craving Gyan channel has come up with startup bundle package, small groups, all-in-one and dynamite package. So if you are interested, please call to the number 6301 356 984. See, in my previous video we have discussed this question. See, this question is a part of electronic transducer. What they have given is a sinusoidal voltage is measured by CRO. Vertical distance between the positive peak and negative peak. Positive peak and negative peak corresponds to 8 centimeter they are telling. So this corresponds to 8 centimeter. And can I tell from positive peak to 0? It is 4 centimeter. And from 0 to negative peak, it is again 4 centimeter. What they are telling is each block corresponds to 5 volt per centimeter, nothing but positive peak corresponds to 20 volt per centimeter, 20 millivolt per centimeter, and negative peak also corresponds to 20 millivolt per centimeter. Now what they are telling is then the peak value of the voltage, peak value means positive peak they are telling, right? So it is 20 millivolt. If they are asking peak to peak, then it would have been 40 millivolt. So another trap question. So the suitable option that's going to follow is option 1 is correct. Next question, an SCR is connected across 200 volt battery through 0.2 Henry inductance. If the latching current in the circuit is 3 milliamperes, what is the minimum width of the gate pulse required to turn on properly? So we know that in the case of SCR you will be having 3 junctions and it is made up of PN, and how many terminals are there? You are having 3 terminals. One terminal is gate, right? So when it is in forward blocking mode, J1 and J3 is forward bias, J2 is reverse bias. When it is fully forward biased, J1, J2, J3, all the things are forward biased, right? So what they are telling is this supply voltage is 200 volts they are telling, and the latching current is 3 milliamperes. Determine the pulse width of the gate. So what is the pulse width of the gate they are telling? We know that voltage across the inductor, which is given by L into di by dt. In order to solve this problem, you don't require the knowledge of an SCR. If you are knowing the voltage across an inductor, voltage across the capacitor, it is more than enough. Now what is the value of VL they are telling? It is 200 volts, and inductance value it is 0.2 into the change in current they are telling it as 3 milli divided by what is the value of dt they are telling, nothing but change in time. So you take integration on both sides, what you will be getting is you will be getting this value to be 1000. You will be getting this one to be 1000. Now if I am integrating, I will be getting T into 3 milli divided by 1000, which corresponds to 3 microseconds. 3 microseconds, nothing but option 3 is going to follow. Next question, by applying principle of superposition to the circuit, voltage across resistance R they are asking. Anyway, this voltage source V2 is connected in parallel with respect to C plus J4. So this voltage corresponds to 1 volt. Apply nodal analysis over here. Call this node as Vx. So what I am getting is, I will be assuming all the currents are leaving. When I am talking about left current, it is -1 plus bottom current will be Vx minus 0 divided by 1 plus right side current will be Vx minus 1 divided by J1. Impedance is J1, right? Which is equals to 0. Take the LCM, what you will be getting is minus J1 plus J times of Vx plus Vx minus 1, which is equals to 0. Now if I am taking Vx as common, what I will be getting is J plus 1, which is equals to 1 plus J. So this 1 plus J and 1 plus J will get cancelled. So what I am getting is Vx equals to 1 volt. Vx equals to 1 volt. Nothing but option 4 is correct. Moving on to 70th question, what they have given is, there is a spectrum analyzer with a third order intercept point of 30 dB and noise level of minus 95 dB. Dynamic range is given by, it is given by 2/3 because they are asking for third order intercept point. 2/3 of 30 plus 95. You are going to take a magnitude. So upon solving, what you will be getting is 83 dB. Upon solving, you will be getting 83 dB. Nothing but option A is correct. Moving on to 82nd question, what they have given is, in a plane wave traveling, electric and magnetic energy densities are equal. Yes, it is equal. Electric energy density is more than magnetic field density. It is wrong. Magnetic energy density is 0. It can't be. Why? Means electric field is going to generate magnetic field is going to generate electric field, and this process continues. And precisely if I am speaking, electric field strength is more when compared to magnetic field strength, but densities will remain same. So A is correct but B is wrong. Nothing but option 1 is going to follow. Next question, in a Schering bridge, dial of a variable capacitor is calibrated directly in terms of dissipation factor of an unknown arm. So at 50 Hz, the value of the dissipation factor of an unknown capacitor was found to be D. What is the value of dissipation factor at 60 Hz they are telling? So what you are going to do is F1 divided by F2, if I am taking frequency 1 divided by frequency 2, which is given by In the first case, the unknown capacitor of dissipation factor is D, and in the second case we don't know, so I'm going to take it as X. So X is given by F2 divided by F1 times of D, which is given by, so it is actually K times of D and K times of some constant you will be getting. So this constants you will get cancelled. So what I am getting is F2 value is 60 divided by F1 value is 50 into D you are going to write, which is given by 6 by 5 times of D. Nothing but option 4 is going to follow. Frequency is a function of dissipation factor. Frequency is a function of dissipation factor. That constant term, proportionality constant term, I am going to take it as K. For a constant load and supply voltage, two DC series motor will develop maximum torque when both are connected in parallel. Both are connected in parallel. Now you should be in a position to understand the questions are asked based on motors. Motors and generators they are asking. So you have to be very much familiar with respect to DC motor and AC motor, series, shunt and as well as compound motors also you should be in a position to understand. 85th question, velocity factor of transmission line is inversely proportional to square root of dielectric constant of insulation between conductors. So the suitable option that's going to follow is option 3 is correct. Velocity factor of transmission line topic is important. Please go through it. 86th question, at certain loading condition, back EMF in DC motor was found half of the supply voltage. Then the power delivered by DC motor is given by, or it is what? It is found to be maximum. It is not half of the rated power. It is not minimum. It is not double the rated power. It is maximum, right? So the suitable option that's going to follow is option 2 is correct. Back EMF concept is important. Especially in the case of brushless and sensorless motor, you are going to make use of back EMF concept. 87th question, the preference for NMOS when compared to other logic families arises. First option what they are telling is, as it uses more silicon area, as it consumes less static power, as it utilizes smaller silicon area, as it is having higher input impedance. Now look at over here, if you are talking about NMOS, you compare with respect to CMOS. It uses less silicon area is correct. It uses more silicon area is wrong. Static power dissipation in the case of CMOS is less, but in the case of NMOS it is more. NMOS is going to offer little bit higher resistance when compared to your CMOS. So D is also wrong. So the suitable option that's going to follow is option 3 is correct. 40th question, match the following. A ripple factor. Ripple factor is given by square root of IRMS divided by IDC whole square minus 1 with under root. And ripple factor of L section filter, it is given by root 2 divided by 3 into 1 divided by 2 omega C into 1 divided by 2 omega L. A ripple factor of induction filter, it is given by 1 divided by 3 root 2 RL divided by omega L. Percentage of regulation is given by RT divided by load regulation into 100%. Nothing but option 2 is correct. See, in the case of analog electronics, they are focusing on some technicality terms with respect to ripple factor, crust, RMS voltage, average voltage with respect to half wave rectifier, full wave rectifier and bridge rectifier. So these things are important. Please go through it. So already this question I have discussed in the previous video. Since it's an important question, I am discussing here also. Moving on to 88th question, what they have given is, in an open circuited PN junction, the contact potential difference is given by, it is also called as built-in potential, which is given by KT divided by Q into ln of NAND divided by Ni square. This KT divided by Q, you can call it as thermal voltage. And NAND is the hole concentration as well as acceptor concentration, and Ni is intrinsic carrier concentration. And if I am talking about pure semiconductor, nothing but intrinsic semiconductor, N will be equals to P will be equals to Ni, or NP equals to Ni square, mass action law. So the suitable option that is going to follow is option 2 is correct. 89th question, in the case of DC generators, wave windings are preferred for. See, we are having two windings, one is lap winding and the second one is wave winding. So what they are telling is high current, low voltage. It is wrong. High current they are telling, it is wrong. So it is low current but high voltage. Nothing but C is correct, A is incorrect. Nothing but option 3 is going to follow. 90th question, the correct combination of characteristic equation of SR flip-flop is, SR flip-flop is S plus R bar Q and JK flip-flop is JQ bar plus K bar Q, and for D it is D only, and for T it is T XOR with Q. So these things you have to remember. So it is S plus R bar Q, it is correct. JQ bar plus K bar Q, nothing but option 4 is going to follow. Arrange the following in terms of decreasing order of their propagation delay. So they are telling RTL logic, emitter coupled logic, transistor logic and CMOS logic they are telling. So we know that CMOS logic is the slowest logic and delay will be more in the case of CMOS logic. So first should be CMOS followed by RTL, next TTL. Emitter coupled logic is the fastest logic. So delay will be very much less. B should be at last and D should be at first. So the suitable option that is going to follow is option 3 is correct. Match the following. List 1 they are talking in terms of time domain. List 2 Laplace transform they are telling. Sin omega t is given by S divided by S square plus omega square. Cos omega t is given by omega divided by S square plus omega square. Sin h, nothing but a hyperbolic function if they are telling, it is S divided by, for sin it is S divided by S square minus B square, and for cos hbt it is given by omega divided by S square minus B square. In the case of monolithic phase lock loop, the equation of free running oscillator frequency of the voltage controlled oscillator is approximately equals to 1.2 divided by 4 times of R1 times of C1. Nothing but option 4 is going to follow. The pin signals of 8051 microcontroller are as follows: PSEN bar, read bar, EA bar. So you have to arrange in a ascending order. So if I am arranging in a ascending order, what I am getting is CBAD. Nothing but first will be, next will be RD the whole bar, next PSEN bar, next will be EA the whole bar. Nothing but option 1 is going to follow. If at all if you are preparing for December 2020 exam or Jan 2021 exam, Craving Gyan channel has come up with startup bundle package, small groups, all-in-one and dynamite package. So if you are interested, please call to the number 6301356984. Moving on to 95th question, what they have given is, in a 10-bit PCM system, a message signal having a maximum frequency component of 4 kHz is to be transmitted. If the bit rate of the PCM is 60 kilobits per second, then the appropriate sampling frequency is given by. Again, this question is a conflict based question. UGCNET they have given the key answers as 8 kHz. But in my Telegram group, when I discussed, many of them have told it should be 6 kHz, it should be 8 kHz. So 7 and 9 kHz, anyway it is wrong. If I am talking about a sampling rate, sampling rate is given by R times of TS, where TS stands for sampling frequency time interval, which is given by, if I want to calculate in terms of frequency, if I want to calculate, it is 1 divided by 10, because it is 10-bit PCM multiplied by, if I am taking an inverse of this, so what I am getting is a TS inverse will be 60 kilobits per second, so it is 60k. Now what I am getting is 6 kilohertz, right? But what they are asking is appropriate sampling frequency. See, if I am talking about sampling frequency, we are having 3 variants of sampling frequency. The first one is undersampling, and the second one is Nyquist sampling. In the second case it is Nyquist sampling, and the third case is oversampling. In the case of undersampling, what you are going to do is, we are going to take Fs is less than 2 times of Fm, but if you are doing so, aliasing is going to occur. But in this case, Fs equals to 2 times of Fm, But in the oversampling case, Fs is greater than 2 times of Fm. Appropriate sampling frequency means, so it is Fs equals to 2 times of Fm. Fs equals to 2 times of Fm. What is the message frequency? It is 4 kilohertz. So I am getting sampling frequency which is equals to 8 kilohertz. 8 kilohertz, nothing but option 3 is going to follow. UGCNET have solved like this and then they have given the key answer as 8 kilohertz. Comment your answers in the comment section. Is it 8 kilohertz or 6 kilohertz? The Haber-Bosch model of the emitter current is given by. So in this case it is A11 exponent of VE divided by VT minus 1 plus A12 exponent of VC divided by VT minus 1. If you can able to remember, it is well and good. Moving on to 97th question, what they are given is the contents of which memory location is transferred to register AL after executing the following 8086 program. So first instruction is MOV CX, 2050H, nothing but 2050 address is sent to or is copied to CX register and it is transferred to data segment. Now what they are telling is move AL, the address, nothing but the contents of F025 you have to take, right? So what is this value? What is the address you have to take? They are asking. So data segment is holding 2050H and offset value what they are given is F025H. Now how to calculate physical address? Now the physical address is given by data segment into 10 in hexadecimal. The physical address is 2050 into 10 in hexadecimal or 16 in decimal plus offset. What is the value of offset? It is 7025H. So what I am getting is 20500 plus F025. So what is the address you are sending? It is 2F525H. So the suitable option that's going to follow is option 3 is correct. How to calculate physical address means it is given by segment register into 10 in hexadecimal plus offset. See, what is the first instruction you are going to write is move AX, at the rate of data, move DS, AX. What tells means the data segment will be storing input and output variables. Which one you are going to fetch or which segment you are going to fetch is data segment first. So you have written DS, any register you can take, AX, BX, CX, DX, any value you can take. And what you are going to send means the contents of 2F525H you are going to send to AL register. That is an 8-bit data. 98th question, which of the following parameters describe a good current buffer? So for a good current buffer, we are in need of low input impedance and high output impedance. For voltage amplifier, we want high input impedance and low output impedance. And for current amplifier, low input impedance and high output impedance. Even for current buffer also, it's the same. So the suitable option that's going to follow is option 3 is correct. 99th question, till now if you are not like the video, please give it a big thumbs up. Also don't forget to subscribe to my channel Craving Gyan. Which of the following uses slow wave structure? A reflex klystron? No. Traveling wave tube? Correct. It is also referred as TWT. Magnetron? No. Gun diode? No. So the suitable option that's going to follow is option 2 is correct. Last question, read the following statements regarding antennas. First statement what they are telling is the rhombic antenna is a non-resonant antenna. This statement is correct. What the second statement they are telling is Marconi antenna is not a wideband antenna. Even this statement is also correct. This question is from paper 2 2017. Same question they have asked. On antenna is best excited from a waveguide. Even this statement is correct. So statement A, B, C is correct. Nothing but option 2 is going to follow. So in this video we have discussed question number 76 to question number 100. In my previous video I have discussed question number 1 to question number 75. Put together I have discussed question number 1 to question number 100. If you have followed with the solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.